So CIS40A, in this video, part 2 of Unit 3 lecture, I'm going to go over router, multiple layer switch, and other network components and appliances. So the router is very important in a network. It is a way that we can connect one network with another network. As you see at home, you're using a wireless router to connect your home network to the internet service provider network. It is responsible for sending data from one network to another network using layer 3 of the OSI model. So it uses the protocols that are affiliated with the layer 3. And other type of switch, or what we know as the multi-layer switch, is also capable of routing and transport and so on. So if we want to send data from one system, from one network to another network outside of our home or business, we would use a router. So everything before the router would be considered the local area network, and everything beyond the router, that will be the wide area network, where it is no longer your own network, but other people's network. So the router allows us to interface with other networks, and routers can come in different flavor. Sometimes you would have wireless router, as you see at home, but other times in an enterprise network, you would see a physical appliance that have a few ports for connection, sometimes fiber, sometimes Ethernet, sometimes coaxial, and others that would be able to connect to the service provider for that company, and they would have their own router and autonomous system to connect to other networks. Router work with layer 3, so it uses IP addresses, and logical addresses would then be able to for the router to be able to identify which network is that system belong to. So the router will pass it to that network, and the switch would then be able to be used to narrow down the subsection of that network. So router has a table which is on the memory that stores information about route. It is a quick way for the system to refer to that table, so that way it doesn't have to look up the route every single time. It would just use the same route for the same type of system. In the diagram here, what you see is you see different branches: Los Angeles, Miami, New York, and or it could also be across the world in Amsterdam and Paris. So we would connect our company branches, right, networks across using router. As we would go from one geographical location to another, we have to go through either an internet service provider, or if you have dedicated line, you would still have to connect from one router to another. Now we can also look at multi-layer switches, and multi-layer switches can be used within our network to really separate different part of our network for different reasons. Security reasons, right? Accessibility reasons, and so on. So there what you see is the core 1 and the core 2 is going to connect to D1 and D2, A1 and A2, and so on. Those are going to be on the internal side, where the router would then interface with other routers on the external side. There is another diagram for the network. So on the left, you have switch, which is represented with left and right arrow. Compared to the router, you would see all 4 directional arrow, and that's usually round. So the switch can be used to connect your systems, your PC, your printer, your servers inside the network. And then the router would then connect our network with, sister's company's network or vendor's network. And it is a good way for us to filter our network traffic through the router, as they would act at either broadcast domain or other type of domain. So traffic cannot cross over the router unless it's destined for that. So its job is to really route the traffic to the target area or the destined system. Now, on the multi-layer switch, that can function as the router, and it can go above layer 3, it could go to layer 4 or layer 5. And sometime in a voice over IP type of network, we would need multi-layer switch in order to support our phone at our desk that's using our digital network. We can also use our switch to create subnetwork that is using different IP addresses to isolate different part of the network. Now, in the next section, it talks about collision domain. And collision domain potentially is just a way that we can assist in how we would look at data that would be colliding from one system to another. You would use a switch that would connect to the systems and on that segment. So when data is sent on that switch, then it would be able to send on a certain port that reduce the collision, but there is also a chance for collision. So if another system is sending the data at the same time, the data will collide. So as we dedicate each port on the switch to create separate collision domain, we would reduce the domain aspect of our network. For the broadcast domain, all the systems in this group would receive the messages from another system. So let's say if one system is sending out message to all systems, we would see this on the broadcast domain. And broadcast domain is just a group of systems that receive the messages. So if we're using a hub, the hub would broadcast to all the systems that are connected to it. So if you want to control which system should receive the broadcast message, you would use the router, and so that way the router does not forward that broadcast message to other networks. It would then specify how that router would route that message to a destined systems. So the router would receive the multiple broadcast domains, so we can connect multiple broadcast domains together using the router. You can also use VLANs on the switch, in which VLAN can also represent different broadcast domain. So broadcast domain simply is just you have one system sending to all, and you might have multiple domains like that. And in that way, if you're using a router, you're able to really have it destined for the systems that are not receiving, and that would allow you to also control the flow of your data or your messages. So in the questions, it asks you for number 15, what is the purpose of the routing table? Routing table is used to store route information. It's used to determine how each of the system is on the destined network. So routing table is a reference on whether that data is intended for a certain destination as it would route. It also contains the list of routers that's nearby, so that way it can quickly pass to those routers. And we will see this later on when we configure the router. We would explain the functionality of the multi-layer switch. So the multi-layer switch provides filtering and routing in the network. We can use it for different functionality like VLANs, voice over IP, routing from one part of the network internally to another part if we want to isolate those networks. For 17, it asks you what type of network devices can be used to control collision domains. We would use a switch to send the data to the port that is destined for the system that would reside, which prevents collision. The switch would be a better choice than the hub. For 18, what type of network device can be used to create broadcast domains? We would use the router or multi-layer switch with the VLAN capability. So a router or multiple layer switch would be best for broadcast domain. Next, we're going to talk about gateway on the network. So the gateways are responsible for translating information from one format to another using the OSI model. The typical gateway would ensure your system that from one environment, the information from that system is accessible in another type of environment. So this is how we're able to have data from our part of the country to different part of the country or across the world. So the example of this is shown on page 13. When the packets reach the gateway, it would examine the packet, it would strip it down so that way it is understood. Now it would translate and it would be able to format it for the system that's intended to receive it so that information can be presented to that system. You can look at the default gateway, and often you would see that the IP address for the default gateway is going to be your router. So your wireless router at home, its job is also the default gateway. In the next part, I'm going to talk about firewalls. And in security class like CIS27, we touch on firewalls a little bit more. And later on, you will have a lab that we will look at security appliance. But when you set up filters on your wireless router at home, you're using a functionality for the firewall. If you're using Windows Firewall on your Windows 10 PC, you are using a filtering system, so that's basically a firewall functionality. So the firewall can be a physical appliance or it could be a software. A firewall is a component that is used to protect the network from external or just intruder or unauthorized user. So firewall is designed to block a certain type of traffic, and we can allow a certain type by setting up the rules, or we can also block a certain type by setting up the rules. We can also set up the rules that is going to be port specific, that would tie to the service, like HTTP uses port 80 or DNS uses port 53. We can block a certain type using, specify rules with the type of device using addresses. So you can choose different ways to really allow or disallow services or systems. Intrusion detection system is commonly found in a network environment. This is an alarm system, so it only detects in the case where there's suspicious activity, it would raise the alarm. It is an important device, but it is reactive in the security measure. Now, there are two types of intrusion detection system. You would have a host base or you would have a network base. So the host base, it would then monitor that particular system like the server. So if you want to use a host base on the computer at home, you would have the software installed and it's going to check for suspicious activity. Or sometimes you would implement that on a certain server. The network-based IDS, it would monitor the overall network traffic. So on that scale, it would be heavy in the actual monitoring. So it's looking at the behavior, the type of traffic coming through. So in the case if you have, denial of service attack, it would raise the alarm because that is a malicious form of traffic where it would look at the pattern. So in the denial of service, your system will be overloaded with a certain type of traffic. So at that point, the IDS would then detect it, raise the alarm, and then we would want to be able to defend our network in that sense after we receive the flags. Active IDS will monitor the activity, logs, or any form of issues on your network. Now, it also allows you to correct the problem. So active IDS becomes what we would see as an IPS, which is Intrusion Prevention System. This allows you to block or prevent activities that could be malicious. So it would do a port scan, it would check the log, and then in the case where there is suspicious activity, we can also logically disconnect or disable that port when that happens. The passive intrusion detection system, it does not take corrective action. It is only an alarm system. It would notify the administrator in the case where activities are suspicious. So going back to the assignment, it asks you first for 19, the purpose of the gateway in the network. It ensures that the system in one environment can access information from another system in another environment by translating that information into a format that can be accepted. For question 20, the administrator wants to use the network device to monitor network traffic for suspicious behavior. We would use the IDS to monitor. And keep in mind again that it doesn't prevent, so IDS simply is used to detect and raise alarm. 21. The primary difference between a passive and active IDS is that the active IDS will monitor the activity of the network, looking at log, and it's going to try to identify any suspicious activity. Then it's going to take some corrective action. And the passive IDS does not take any corrective action. It simply just is a monitoring system. In the next part, we're going to talk about wireless. So wireless access point, WAPS, is a network device that's connected to the wired network, but it's going to offer wireless connection to the client or the system, mobile systems, or systems that wants to connect wirelessly. Wireless access point is also known as a cell, and it transmits and receives radio frequency between the device. And WAPs can connect to a physical cable. As you look at your wireless router at home, you would see that there is a WAN connection which connects out to your internet service provider. And then LAN connections, you will have multiple ports that would then connect to your desktop or other systems that would have the cable wired physical interface. You can also implement wireless range extender. It's simply take the frequency or the signal and it would rebroadcast it. So that way other devices further in distance can receive it, and we would have ideally more reliable connectivity. Now, on the voice over IP, which is used for the phone network, we would see voice over IP endpoint. These are the device and software that is for phone call. So if you're looking at the phones that are used in the voice over IP network, they're treated as device or systems. They have IP addresses. They would be connecting, and those phones have an encapsulation feature in that it would take the analog signal and be able to convert it into digital signal before it transmitted. Your smartphone also does that. So the endpoints for the VoIP, that could be your voice VoIP phones, as we talked about, and it can typically use a network switch, and we would implement layer 4 switch, and or a switch that's capable of power over the Ethernet. Now, your computer system, like your laptop and desktop, is capable of using microphone and headphones or speaker to be able to make phone calls. So in the case where you're using video conferencing, internet calling, that is using a software that's going to be able to submit the signal. And on the operating system level, there's an application that allows you to do that. You can install an external application, or some operating system will have that capability incorporated. So for our questions, we will get to Brian and Isdn information. But here in the older network, we would use an analog modem. This is used phone line or analog signal to be able to connect. So it basically transmits information over the phone line, and it's designed to convert the modem itself. It's actually the modulator. It converts analog signal to digital format, and so that way the system can read it. We would also have channel service unit, data service unit, CSU, and DSU. So make sure that you, even though now you might not see some of this regularly, you would need to know for Network Plus and for the industry. So CSU, DSU is either one device or a pair of devices. It allows us to connect to the high-speed WAN using what we call as T1 or T3 link. And this is just a connection type using copper line. CSU is used for the business end, and some internet service provider would provide T1 or T3, and this is older. It's about 20 years ago that we would use this. And DSU is used for the provider end to allow CSU connect. In the next part, we're going to talk about Isdn, and this is an older technology. It's called Integrated Services Digital Network. This was used to send voice and data over telephone lines and digital telephone lines. There are organizations still use Isdn line as a backup line, or even a T3 or T1 as a backup line. So this type of information, even though it's older technology, it might be useful to you if you come across this type of technology. So to connect the Isdn line, you would use an Isdn modem. And that modem is then going to convert digital data to analog. And that modem carries the digital data from one system to another. So there are two types of Isdn. There's the BRI, which is your basic rate interface, which connects at 128 kilobit per second, which is made of two 64 kilobit per second channels, known as B channels. And on 16 kilobit per second control channel is known as channel D. So what you see is it's going to couple two channels, 64 64 kilobit per second to give you 128. Or if you're doing, if it couples the one, or it would include 16 kilobit per second control channel. On the primary rate interface, the PRI, it uses this is the throughput for it is 1.55 megabit per second, which is much faster than the basic rate interface. It's made of 23 64 kilobit per second channels, so it has higher group of channel, and it's going to use one 64 kilobit per second D channel for signaling. So the main difference between the PRI and the BRI is that the PRI is faster, as it would group more of the B channels, and also its D channel is a higher throughput. So in the question, it asks you, what is the different or compare and contrast between the PRI and the BRI? You can state the information that's provided in the notes. That BRI is 128 kilobit per second. It uses two 64 kilobit per second channel and one 16 kilobit per second channel. The PRI, it is connecting at 1.55 megabit per second using 23 64 kilobit per second channel, which is B channel, and one 64 kilobit per second D channel. The next part we're going to talk about is advanced network devices. We might have encryption devices that would be used to encrypt certain traffic. We also would have load balancer. You commonly see load balancer in the network. It is an appliance that would split the workload across many servers to really help the performance, so no single system is going to handle everything. And this is very common for websites or that would be connecting to web servers. Your proxy server is a device that's used to request internet resources such as web pages on behalf of the internal users. The benefit of using it is that proxy server would then filter what website the user can visit. It would store that information so that way it could be quickly accessed. You can also use it to manage internet log activity and control what type of protocol would be used for internet resources, so it would filter. We would have appliances that would do content filtering. So content filtering allow the user to access the internet, but you can filter specific URLs or even sometimes key terms. Vpn Concentrator is for virtual private network. This is an appliance that allows multiple clients to connect securely to the office. So nowadays in COVID-19 era, we would see VPN Concentrator being utilized quite a bit. It would encrypt the tunnel and it would enforce the rules and making sure that the connection is secure. There is Packet Shaper, and Packet Shaper is known as traffic shaping device. It's responsible for just delaying certain type of packets to make sure that the bandwidth is available for other packets. So in the case that if certain type of packets is demanding more resources, you can use Packet Shaper to delay it so other traffic will go through. And this is mainly used for like voice over IP type of network. Multilayer switch, we touch on that. And also the other one is wireless controller. This is just used to deploy wireless configuration across the network. So we can use the controller for settings like channel selections and power for access point using lightweight access point protocol, your LWAPP. This used to deploy and configure wireless local area network. Then you also see AAA or radius server. This is used for authentication. So AAA stands for authentication, authorization, and accounting. Radius is a way that we would centralize authentication, wireless, wired, and VPN services. So Radius is often affiliated with VPN, but in order to connect to VPN, we want to make sure that we authorize after we authenticate, and we would be accounting with privilege control. UTM appliance is Unified Threat Management. This is common for security appliances or multi-functional appliance. It would be built into a firewall or IDS or sometime all-in-one type of system where that system is capable of VPN, firewall, intrusion detection, and prevention. Then we also have Ngfw layer 7 firewall. This is known as the next generation firewall at the application layer, which is the highest layer for the OSI. This inspects application data and for malicious packets. So when you put the application server or some kind of web server, an application server that will be exposed to the web via the DMZ, you would want to incorporate this type of firewall. This firewall would inspect the data in the packet, and if it's determined that there's suspicious activity, it would block that type of data. There's Voiceover IP Ipvx, which is used for IP private range for call switching system. So the old system that was used for telephone is a Ipvx. Now we can actually incorporate voice over IP working with Ipvx system. So that could mean that many users or a group of users can use a single phone number to be able to make phone calls. And it will be directly routed to that particular user using extension. So most business that you see, they have some form of extension to the certain voicemail or voice box. So that way the user can receive the phone call and also voicemail. Voiceover IP Gateway is a device that converts phone traffic from public switch telephone network to IP packets for the local area network. And that will be so similar to what you see with the router, but this is used for voice, for phone voice over IP only. So going to the assignment, we can answer number 23. It asks you, why should a balancer be used in a network? This appliance allows you to split the workload across multiple servers. This helps improve performance, so no single system is handling everything or all the requests. This is often used for web servers. 24, it asks you the benefit of proxy server. This is used to handle requests for such as internet web pages, and it would cache that information so it can quickly serve the web pages. And we can also use it to filter certain type of URL or website that certain system is trying to access. We can use it for logging network activity or internet activity and controlling protocols that's used. In the next part, we're going to talk about virtualization. And virtualization is common technology now in that most networks, instead of buying many physical server, we can buy a few server and be able to adapt many of the virtual machines to handle services like authentication, DNS, web, database, and so on. When you're using cloud technology like AWS and Azure, you would see that there are virtual machine capability. For example, on AWS, you would see the EC2 and so on. So virtual machines is using RAM and storage space on the hard disk. As for operating system, it would require some kind of software in order to be able to access that. But we would then be able to reduce the hardware costs and the hardware requirements for multiple systems where we can use one system with multiple virtual machines. We simply would run the operating system, multiple operating system within the virtual machine using hypervisor, and hypervisor would, which is a software, would allow us to incorporate functionality for multiple virtual machines that we want to adapt for our network infrastructure. So in the case of VMware and Hyper-V, this allows you to run many virtual machines environment. And there are other products like, VMware vSphere and so on. So hypervisor is known as Virtual Machine Monitor, or your VMM. This is a software that allows you to create and run virtual machine. So when you install the hypervisor on the system, your system that's being installed on is known as the host system, while virtual machines are just known as the guest system. Type 1 is the hypervisor software that runs directly on top of the hardware. And so the host operating system is running as the parent virtual machine. This allows the software or the hypervisor to access your hardware directly from the host. So Hyper-V and VMware ESXi is an example of type 1. For type 2 hypervisor, it would install OS being installed on top of the hardware and installing virtualization software to create virtual machines. So VMware Workstation, Oracle VM, VirtualBox is of type 2. And we commonly use type 2 in the scale-up education environment, but in a business network, you might have a mix of type 1 and type 2. Virtual network components, you would see that when you install the software, you would be able to incorporate the network components with it. There's virtual switches, allow you to place different virtual machines and group them together. Virtual routers that allows you to route traffic for your virtual machines. Virtual firewall, we can use it to filter traffic leaving a network or entering a network. Virtual network interface card that allows you to use your to connect your virtual machines to the real network or also the virtual networks. Software-defined networking, which is your Isdn, is just a strategy that separates networking functionality and with the control plane and the data plane. So in this case, it would create a manageable network that would be, we can change configuration quickly. Virtual desktops are a system that will be stored on central server. Something like Hyper-V would have this. And, you would use a thin client, which is a smaller, minimal hardware system to be able to connect to the server. And then from the server, it's then going to be able to obtain the desktop so you would be able to use. And companies would use this to reduce costs. However, network connectivity is going to be essential. Virtual servers are used to provide services to physical and also virtual systems. And it would use virtualization technology like Hyper-V or VMware, like vSphere. So this will allow us to reduce costs. Instead of buying many servers, like I mentioned before, we would be able to buy fewer servers and then be able to support it with the software. Virtual PBX is private branch exchange PBX system that's used for phone services. It offers service phone provider for the company to do not need to have to buy the entire system, but to use the software to do that. So to answer the questions in the next part, for question 25, it asks you what type of hypervisor is Microsoft Hyper-V. And this, we would say that that will be type 1, as it would run directly on top of the hardware. And the host operating system would be the parent virtual machine, using the hypervisor to control the access of the hardware for host and the guest system. So now we are going to go over cloud computing. And cloud computing is simply that we're using servers or network that would be owned by another company, and we would use internet or multiple network connections in order to be able to access the actual resources that were provided by the hardware of the other companies. The benefit of this would be we would not have to purchase the equipment, so no hardware costs. We would just have to obtain or pay for the subscription of our cloud. It can scale, and so in most cloud options, you would be able to have what's called elasticity. That will be pay per use or we can range it and then scale it out to something that would match the company's need. So that allows us to be able to be more flexible and along with the high availability. But again, this is going to be internet dependent. That means that we have to connect. And so if we don't have internet connection, that means that we won't be able to access another network elsewhere remotely. Focus on software configuration. We can have the server up and running very quickly without having to configure all the hardware, as that would be done. Now, the security side of this is that a lot of the times, right, company contract with cloud computing would require at least 50-50 or even higher percentage of the subscriber responsibility with security. So the cloud company would provide the hardware and the maintenance and the support behind it, but on the configuration and the security side, it could be solely responsible by the subscriber, or it would be mostly the high percentage for the subscriber to configure security and maintain their networks. Cloud delivery model falls into a few categories. First is the public, that you will be able to subscribe, where you would use the internet to connect to it and you would pay a monthly subscription. So that way you would have storage and so on. Private cloud, that would allow you to host services at the data center that you own, and you would implement security like firewalls and so on to be able to protect. So that will be a little bit more expensive, but if you have proprietary data or confidential data, this is probably one of the best options. But there are companies that would be able to fulfill the requirement. Then you have hybrid cloud solution, which has both cloud, public cloud and private cloud, so you can have a mix of those. Community cloud is where multiple companies share the same cloud of services, so that way it would cut the cost as long as they achieve the same goal. The cloud services would fall into a few categories. such as IaaS, Infrastructure as a Service. This allows the cloud provider to host virtual machines that you would use as network infrastructure. So virtual machine could be for your servers to authenticate, to provide web services, to provide application, and so on. Platform as a service, this is where we would implement development, building the solutions for websites, database, and web services, so PaaS. Software as a service is where it involves providing user with web browser to be able to access certain type of software like Office 365 or Google Docs and so on. Desktop as a service, that would allow the service provider to provide desktop virtualization services, so you can access your system desktop via connecting to the provider networks. And for cloud connection, we would use internet connection. So if we don't have reliable, good internet connection, cloud solution will not be suitable for the company. There is security implications. So in order to meet the requirement for security, the organization is required that the things that are stored, right, the things that are maintained by the cloud company also need to be governed and follow compliance and regulations. Now, we have to look at the relationship between the local and the cloud resources. If we want to use hybrid cloud environment to store data locally, and we want to host services locally, how is that going to translate to if we want to put other data and other services into the cloud? So before we move into cloud implementation, we need to take a look at what do we need locally and what do we need remotely through the cloud company. So to answer the last part of the questions here, it asks you what type of cloud delivery model consists of multiple companies sharing the cost of the cloud. That will be your community cloud. 27, when implementing the cloud, what should the company consider? We want to say reliable internet connection, strict security policy for data access based on regulations, and the relationship between local and cloud for data storage and services. Then going into the network attached storage and different type of storage. So network attached storage, your NAS is used to store files. That can be done at home or usually happen in business. Your NAS is normally a device, it's a computing system, and it would have multiple location for hard drive or solid state drive, or sometime RAID, which is a group of disks that we can write across, or we can group up these disks to store our data. NAS would then also be treated as file server. So for the NAS category, we would have storage area network, which is your SAN. And this is a centralized location where we would store our file. So in order to access it, the user would then need to connect to that particular system for storage. Now, storage connection can be fiber-based, so we can use fiber channel, which is going to make it fast. And we would use the interfaces and the cable, but it would be costly. So fiber networks can transition or improve the performance for your network. However, it would be high in cost. Your ISC-SI This is a protocol that encapsulates your small computing interface commands into in a packet, and this would be sent across the Ethernet network for the server. So you can use this to access remote storage, and you're able to use your existing network. You just have to implement the initiator software to connect to the actual system or server. FCOE, you can use ISCSI, and it used fiber channel over the Ethernet, very similar to power over the Ethernet. We would have fiber channel over the Ethernet. This will allow you regular network connection carry on the fiber channel. InfiniBand, this is a newer type of standard which uses fiber channel and Ethernet on the high speed using technology to interconnect the components. So jumbo frame, this is just a way that we can frame the data at higher bytes. So anything that's more than 1500 bytes, that will be considered a jumbo frame. And the 1500 bytes is the default maximum for the Ethernet frame. So in the network devices can have jumbo frame be enabled, so that way you can send higher byte size data. Now, the benefit of this is that it would reduce the overhead for sending large amount of data that would be smaller. We can send jumbo frame in chunks of larger byte size. So that will help our network traffic. So in the next section, it asks you to identify the types of network storage connections. We had touched on that, and you can refer to the notes on page 20 to provide you with the details. For 29, we talked about jumbo frame, how the frame can reduce overhead by sending large quantity of data when we send less quantity of data but larger in bytes. And you can refer to page 21 for jumbo frame. For number 30, the type of industrial system your ISC that would use to monitor and manage equipment in the production plant. So equipment for production, and you would see this in manufacturing, for example, that will be Scada. So in your notes, it talks about what Scada is, and we would also have Network Plus question. This is a new topic area for the new certification version. So Scada is supervisory control and data acquisition. This is a type of system that would be used for industrial environments. It would be used to remotely control equipment. So under Scada, you would see Industrial Control System, your ISC. And ISC server is a server system that would receive information from the devices, and it would send that to the supervisory commands it would use the device, the commands to send to the device, so that way you can operate the device. Then you also have DCS, closed network, which is known as distributed control system. This is a control type of system for plants that would distribute to another number of systems that is connected to the network, so that way it will allow them to connect. So basically it controls the systems that are connected in a distributed network. The remote terminal unit, your RTU, is an electronic device that connects to the DCS. So in order for the DCS to work, you would use the remote terminal unit. Programmable logic controller, your PLC, is used to monitor and control machinery. and it can be programmable. So therefore, we would say that it is programmable logic controller. It would be able to handle higher temperature or low temperature, and it's resistant to vibration and immune to interference of electrical noise. Another thing that you'll be asked on Network Plus is going to be your media nets. And this is for voice, video, web pages, and other form of media that's to be delivered. So considered rich media. And MediaNet is a network design type based on what the business would be. So if the business is using a lot of streaming, a lot of video teleconferencing, a lot of graphic-based type of services, then it would have what would be called media nets. So for our questions for 31, it asks you what type of system consists of network that has been optimized for voice, video, web pages, and other form of media, like rich media. That will be your media nets. Now we're going to go into the physical element of our network, which is the physical equipment that's non-electronics, that will pertain to racks and things that we would mount our appliance. So in the wiring distribution system and the rack system, you would have what's called plenum. And on the Network Plus, you will be asked about plenum. So this is a space between ceiling tiles and the floor. And this space is typically used to route power and cables. So you have the ceiling tile and a second level where you would be running the cable. So there would be a cover, or sometimes you would have a raised floor. The subfloor would have a gap where you would be able to run cable and power. Now, it's important that you would use a different grade of cable, because in that case, it would, allow you to be more safe for the individual, the people that work there, because other type of cable would release the toxin when it catches on fire, which is known as your PVC cable. So your normal cable has the plastic covering, which is the polyvinyl chloride type of cable, and that can cause harm when it catches on fire. So we want to use plenum grade cable. Then you also see what's called a patch panel. And patch panel is used to connect cable to a certain port of the switch or even other network appliance. Using patch panel can help in cable management. And you also see patch panel being used in different type of medium outside of copper or UTP. You would see also on fiber. So when the computer connects to the network jack, the patch panel is then would be mapped to a certain port. So when you have different offices and room that would have network jacks, and those jacks would then connect back to what it's called a patch panel, which is then connect to your switch. And we want to make sure that we label and we want to maintain the patch panel so it will be easy for us to manage down the line. Then here it talks about cross connects and MDF and IDF. So MDF stands for main distribution frame, and IDF is intermediate distribution frame. So in the network, we would have line coming into the building. That would be considered, the panel for that would be main distribution frame. And the main distribution frame would then connect to other panels that would be under that. So that would be intermediate distribution frame. So the purpose of this is to have a way to organize our network and scale. And so when we use patch panel, we can use that patch panel to connect, which is what's called horizontal cross connect, your HCC cable. And the cable that's used to connect MDF to IDF, that will be vertical cross connect, your VCC cable. So from patch panel to other patch panel, we are horizontal cross connect. The cable that connects MDF to IDF, we would use VCC or vertical cross connect. Every network, including your home network, has a Dmarc. This is known as the demarcation point, and it's just used to identify an equipment that would connect to the building. So if you go out on your street near your home, you might see either it's right outside of your house or it's in near the sidewalk where you would have a Dmarc point. And that's where the service provider side is going to connect. So in the case where they need to fix or troubleshoot, that's where it's going to go. You might have Dmarc Extension, where in a business environment, you would have patch panel connect to the provider line using Dmarc. It's known as the Dmarc Extension. So that's what you would see there in the picture. Smart Jack is a term for Dmarc point. This is to connect and be able to diagnose the issue. Fiber channel, fiber distribution panel, fiber and distribution panels are considered fiber patch panel. And this is where we would terminate fiber optic cabling. The rack systems, you would see that in either data center or server rooms. Rack system is used to connect servers, routers, switches all in one location. Some racks are U-mount and some racks are other type of mount. So make sure that you check the type of rack that you're working with. And so that way, you know, because some system will fit a certain rack mount. And so if you can't fit it for a certain rack mount, then we would have to buy a different form of rack. So in data center, you would see something like this. And so we want to monitor our rack looking at temperature, humidity, power in real time. So our system needs to run cool and it needs to be dried, and we want to make sure that we have plenty of power to support it. So there might be a monitoring system that we would use in order to do that. Okay. So in the last few questions for 33, to avoid toxin that's released by polyvinyl chloride cable, in the case of fire, we would use platinum grade cable. For 33, what is used to connect the patch panel that is used to connect MDF and IDF? That will be horizontal cross connect your HCC to connect patch panel to patch panel. Vertical cross connect would be used to connect MDF to IDF. For 34, what type of labels would you use to include in your network rack? We want to label our ports, our system, our circuit, and our patch panel. And those are the 4 important type of label that you would have for your network. And this concludes my video for part 2 of CIS40A assignment and notes. Thank you for watching the video.